Hello, I'm Jérôme Vétillard. I'm a digital enterprise architect within Microsoft Services, and we are going to share some thoughts for about 1 hour about the utilization of artificial intelligence within the health industry and the health sector in general. So basically, by having a time perspective about the use of artificial intelligence in health, we are going to figure out whether it's a revolution or an evolution of current practices. So let's start with the past. Artificial intelligence computer in health is kind of never-ending story since the inceptions of those technologies. 1976, MyCine. It's the first rule-based expert system to use decision tree algorithm, and it was meant to identify infection cause and then to suggest appropriate therapy. It was a standalone system in which a human operator was assisting the system by entering clinical signs, and based on that clinical representation, the system would do some recommendation. 20 years later, still the same kind of algorithm, but that time we were able to put the whole disease identification graph into the decision tree structure. So basically, it was a general diagnosis expert system in which we were able to separate the symbolic reasoning structure from the knowledge database used to be consumed by that logic. And it was having quite good performance when compared to internal medicine experts. Then we refined the algorithm in which we are transitioning from the Boolean binary logic in which truth variable may only be 0 or 1, and we accepted that partial truth could exist in the system, and partial truth was represented by a variable that could vary from 0 to 1. So with some new operators, we gave more flexibility in the system to converge to the right diagnosis. However, the common characteristic of those systems that they were still relying on a human operator to enter clinical signs, and basically that was the way you could influence the algorithm, and basically it was a human operator assisting the system to converge to the right diagnosis. Last year, Yuval Noah Harari claimed that the AI doctor will replace the human doctor and that this is inevitable. Well, basically the message is we will replace you. But is it true that an AI-based doctor could replace a human doctor? Let's see it in the next slide. So we've seen on the previous slide that when assisted by a human operator that has medical knowledge, that is able to enter relevant clinical signs and clinical presentation, then the expert system is able to converge to the right diagnosis. The revolution in there is that with deep neural network technologies, we were able lately to provide the computer with vision, with listening, and with the ability to somehow understand what we were saying. So basically, we provided the computer with the ability, and I insist on that word, to partially grab the clinical presentation of a patient. And that's the revolution there. These systems don't rely anymore on a human operator to be able to have a clinical presentation. However, the clinical presentation they are going to grab is very limited, and it has been applied with great success to melanoma identification or diabetic retinopathy identification. So very narrow AI. The close question is whether I suffer from the disease or not. And the disease is very specific with very good signal or bio indicator, very specific. And I think that this is the reason why Yuval Noah Harari is saying that the AI-based doctor will place the human doctor very soon. And I think that's a mistake because medicine is far broader than simple diagnosis. During the investigation phase, what's going in there? It's a human relationship between a patient and his doctor. And it's all about establishing trust in between doctor and patient. And the stronger the trust is, the better the clinical outcome will be. Because through the anamnesis, you will be able to grab the whole complete clinical presentation to better understand the patient history, the disease history, and then obviously your diagnosis and prognosis would be better. But far beyond the investigation, we are going to therapeutics. What therapeutics are about is to select the appropriate treatment. Now you know what is the disease, whether it's surgery, whether it's medication in which you have to enforce observance of the treatment, whether it's management of the iatrogene effects of the treatment, and obviously also the treatment adaptation in terms of dosing drug to follow the history of the disease and the history of the patient. And yes, follow is the keyword because then you have the follow up, and it's based on active listening, therapeutic education, rehabilitation, and it's all about medical value realization because there's no need to do surgery if there's no rehabilitation protocol to restore your motion capabilities. And it's achieved through routing you, the patient, through the patient circuit into the healthcare system. Focusing on AI, we've seen that they were involved in diagnosis, but that's the title. Medicine is far broader than simple diagnosis. They are also involved in assisted surgery. We can mention in there virtual reality, mixed reality with HoloLens V2, for example, and obviously the Da Vinci robot for surgery. And they were also involved, and remember IBM Watson in the oncology field about assisted therapy. So how can we define the best treatment for patient? And we know also that has been kind of failure because first of the business model, and we will see it later. Second, about the medical value because basically early stage of oncology, the treatment is based on consensus. So you have guidance and recommendations, and there's low freedom there. And then on the late stage of the disease, when you are in the fourth line of therapy, then you have more freedom to select the treatment, but then you have less impact of the treatment on the cancer history. So basically, low medical value. And at the end, being able to read billions of articles, it's no effect if those articles have not the right quality to improve the treatment. So that was basically what the reason why it failed. And so the message now is not we will replace you, it's you will assist us meaning healthcare professional, and eventually team with us to handle the patient. So let's try to frame out the concept of patient circuit and that concept of healthcare provider system. Basically, maybe you are unconscious about that. The hospital is somehow the alpha and omega of our lives. Think about it. You're born, you grow up, you're aging, eventually you die. All through your life, try to stay in nominal health status. You are helped to do that by public health policies with a preventive healthcare approach. An initial routing through the healthcare provider system is made by the general practitioner. So let's try to frame out the healthcare provider system based on the total cost of ownership out of 1 day in that system, and the length of stay. The first block is the acute stay. It's highly technical beds, which cost a lot, and in which we try to reduce at the maximum the length of stay, meaning that we are using ambulatory surgery to reduce the length of stay, for example. After that, downstream you have rehabilitation with medium stay, long stay, and downstream you have home care, medical social structures, and long-term for dependent people. And basically, we interact with that system, complex system, through complex patient circuit. You are sick, you go to the GP, you are healthy again. You need to go to the hospital, or you have a car accident and you need to go to the hospital and then you need rehab. Or you are an elder and you have an acute event, so you go to the hospital, you go to the rehab. You ended up in a long term for dependent people, or you are unlucky and you straightforward to the final stage. You're dead. And what you can see here, it's a complex healthcare provider system with friction every time you change from acute state to rehab and then to downstream structure, which costs a lot. We have complex interaction, and maybe we need some artificial intelligence based system or computerized system to optimize and to align the demand with the offerings and to reduce the overall friction and cost in the system. So, when dealing with AI usage in health, we are facing two options. On one hand, guys like Yuval Noah Harari will tell you that AI will save the world, but they forgot about the blockchain. But AI is so powerful, But basically, these guys are talking about a non existing AI that is named general AI and that is able of versatility, able to handle different kind of issues, very different issues. On the other hand, you might have tech guys that are AI knowledgeable and that will see that there's nothing as dumb as a deep neural network, especially when trained by a dumb guy. But basically, it's a weighted matrix that takes an entry input signal and will map it to a limited set of output signal through training. That's basically what is a neural network can do. So guys, what is your choice? Do you want the blue pill for a cloudy trip into the marvelous world of AI, the general one, or do you want the red pill for a bad and ugly truth about the narrow AI? So okay, let's try to be smarter than that and just leave the Boolean logic to embrace the Fuji logic and partial truth. Go for the Fuji logic, guys. Going back to the title of this presentation, that is the usage of artificial intelligence in the healthcare sector, we need to define what is the healthcare sector and how it looks like. Here is the French health ecosystem. I want to show you it's a very complex structure by itself. In red, we have the institution, and we will see their role just after that. In green, we have the national agency. In light green, we have the med school, pharma school, and the councils. In yellow, we have the healthcare providers. And basically, that's the area that we best know because we interact with that area on a daily basis. In blue, we have private sector, but also some public research organization. And in white and black, we have the healthcare payers, because obviously we need to finance the whole system. So what about the responsibilities? The Health Ministry of Parliament, it's all about institutional governance. They vote the healthcare budget. They shape the public health policies and they frame the whole health ecosystem. The social security obviously is about budget execution, audit healthcare professional, while the private healthcare payers, they define insurance packages and they engage customers in preventive behaviors. National health agencies, they provide operational support to public health policies, drug safety, they define medical good practices, they provide also statistics and bioinformatics solution to the whole ecosystems for management. The private sector or public research organization, they are into biomedical innovation and the technical enablement of the healthcare service provider. It's all about innovation, patent for portfolio management, etc., etc. And they're here to provide medical, and that's important, medical grade healthcare solutions. The healthcare professional councils, it's all about medical ethics and trust, while the universities, med school, pharma schools are here for initial training, education, and also continuous education. And that's an issue too, because at the time being, continuous education is somehow financed by the big pharmas. Eventually, healthcare providers, so the guys we all know, they deliver healthcare services, they execute the public health policies, and they apply recommendations from National Health Agency. We saw that the healthcare ecosystem is very complex. We also saw that the patient circuits within the healthcare system is very complex too. But furthermore, for any one of us, health and AI have blurry definitions. Being healthy, what does this mean? Well being, quality of life, prophylaxis, or just not being sick? And then AI, what is it? Is it about Internet of Things, wearable technologies and connected health, virtual augmented or mixed reality, next-gen computing experiences, robotic surgery, artificial intelligence as white? Basically, there's no single definition of what is AI, and we could define it as a computerized system that exhibits behavior that is commonly thought of as requiring intelligence. So, what is intelligence? There's the Tesla theorem saying that AI is whatever hasn't been done yet. This concept here is that when you train a neural network to do something, after you train it, it's just computerization. It's no more intelligence because the underlying concept of intelligence is all about versatility. An intelligent system can address different kind of issues and can adapt to changing conditions. Once trained, the neural network, like I said previously, there's nothing as dumb as a trained neural network. So we are facing a complex ecosystem, complex patient circuit, complex definition of what is AI and what is the health. Things are so complex, complex in structure, complex in perception, complex in definitions, then the best approach to such a complex system is to have a thematic approach. And Microsoft tries to reimagine the healthcare to provide better experiences to both patients and healthcare professionals, to provide better insights and better care, meaning same or higher quality at a lower cost. Three pillars in here. First is to enable personalized care. That's a paradoxical thing, meaning that we need to have standardized procedures for drug safety, for to limit iatrogene effects of treatment, but being highly standardized to have an operational excellence approach, we also know to be very personalized to the patient, to rehumanize the relationship. So it's all about a patient centric approach to healthcare. We need to empower the care teams. And we build more effective teams by providing deep insights from centralized data. And it's all about sharing in a secure manner and relevant manner the electronic medical records of patients so care teams could collaborate and provide better care and limit iatrogene effects of the treatments. Last pillar, it's about improving operational outcomes. It's all about streamlining and improving operations using clinical and business data because we need to optimize the operational efficiency of healthcare providers so they can make money out of what they are doing to save our lives. Let's have a look to Microsoft specific realizations in applying artificial intelligence to the health sector. You can see here you have partner-led project, Microsoft research project ranging from reducing cost of MRI CT scan interpretation to the precision medicine, whether it's reading scientific articles or um, being an engine for a genomics platform. As you can see, we are still in the narrow AI domain, so we address one sharp issue at a time. And most of those initiatives are reaching the first minimum viable product stage or proof of concept right now. So the issue behind that, it's about the econometrics of those innovations. Do we have a clear business models? Do these innovations do better than the legacy solution? Better quality at a lesser cost? Let me tell you a short story about one conversation I had with the chief medical officer and the chief information officer and the chief digital officer of big pharma. There was a lot of officers around the table. And basically, they wanted to know what digital could do for their company to improve the sales, to improve the revenues, to improve the margins. And so I started talking about global supply chain management, Factory 4.0, drug traceability and quality. But those guys were interested in precision medicine. So I said, okay, guys, let's assume you have a drug available on the market for a specific disease and you make 100 units of revenue out of this blockbuster. Now you are going to invest cash to build a proteomic, genomics, whatever X platform. And with this platform, you are going to say that for a subset of patients having that disease, the drug will not work. And this is very elegant and smart. Possibly you will reduce iatrogene effects, but let's consider the business side of it. You invest cash to cut off your revenue because now you don't have 100 units of revenue, but 80 units of revenue, for example. So let's have a conversation with your chief financial officer and try to explain to that guy that you need to invest money to cut off your revenues. And worst, it's not you that are going to develop that platform. It's a medtech, and the medtech guys will go and see the Ministry of Health saying that on that disease we can cut off your spending by 10% for only 0.1% of savings as revenue for my medtech company. That's the reality of the digital disruption of the pharmaceutical sector. So the issue is not to apply AI in health, it's to apply it to specific solution. Once again, it's narrow AI and to do better than existing solution. Like for a clinical trial, when you introduce a new drug on the market, once the first stage is to define it does better than nothing. And after that, does it do better than the competitors, the existing molecules on the market addressing the same disease? So it's very alike for AI applied to health. It's does it better? better quality, better outcomes at a lesser cost. And you need really to focus on the cash flow generation and to demonstrate you are going to have a return on investment. AI, big data, smart whatever is not enough to make money out of it. One other AI related subject is that the AI algorithm is basically a new medical device to approve. There are already regulations on the software as a medical device, which insist in particular on the cybersecurity aspect of the device. Obviously, if you can hack a pacemaker, it is not good for the patient. Then the question is, should artificial intelligence be subject to specific regulations? And then we are going to differentiate here edge computing from learning systems. In edge computing, like I said previously, you train intelligence, artificial intelligence, and once trained, you put it in a medical device. So it will just do what it has been trained to do and nothing more. So it's static. Then you can have a learning system that is dynamic, and every time it interacts with the patient, its medical practice is different because it learned from its past experience. And how can you certify a dynamic learning medical device? Then the last point is about the robustness of AI algorithm. Especially, we had some example in computer vision. You can have a picture of a beer, and the AI will say it's beer at 97% confidence. Then you inject some noise on the picture. For a human eye, the noise is almost invisible, so it's still a beer, obviously. But then for the AI computer vision systems, it's not a beer anymore, it's something else. And that poses the issue of robustness of this algorithm. The comparison to autonomous driving can be done. That is, autonomous car on a highway, a few cars around, straightforward, it will perform very well. Now put it in the center of a crowded town with very nervous drivers all around, and it will be a complete mess. So we should keep it in mind that AI algorithms are not the Deus ex machina that are omniscient, can do anything. They are subject to hacking, and their robustness is questionable. Then go back to the certification or approbation. Here you can have a list of different kind of solutions that got their FDA approval question mark. Basically, certifying is different from approving, and you have three classes of approbation. Medical devices are approved class 3 devices. Let's focus on the Apple Watch. It was meant to be an ECG class 3 devices, but anyone who did ECG knows it comes from 12 to 24 derivations and not only two. So Apple Watch is basically a class 2 cardio frequency meter, nothing else. That's a way it can detect arrhythmia, but it's not an ECG. So beware about the level of certification or approbation of the medical device. We still need medical grade devices. And last but not least, the medical device is used by a healthcare professional who can explain the outcome, who can handle the psychological impact of a diagnosis, and who can provide some therapeutic approach to that diagnosis. I don't want to be alone to learn that I suffer from a deadly disease. I need a medical grade device operated by a healthcare professional. I'd like to talk with you now about one critical question, that is the sustainability of our health system. We have major socio-demographic changes ahead. 2 billion people over 60 years old in 2050. We have a strong increase in demand with the cancers, degenerative disease, metabolic syndrome, fourth age increasing, and high-tech medicine. We all know that a cybernetics prosthetic costs much more than a wooden leg. So we have structural cost that goes up at a very fast rate. On the other hand, we have financial constraints, global economic crisis, impoverishment of population, tax consent, and basically we have less fundings available for the system. We have also medical demographics issues because it goes down. We will lack globally 14 million healthcare worker positions in 2030. And how to combat that? We need to improve the professional attractiveness of those healthcare professions. We need to combat medical deserts to improve medical productivity using centralized and shared EMR with a collaboration between hospital and general practitioners centered on the patient. And we have also a big change around the training, initial education, and continuous training of healthcare professionals with and for these new technologies. And the outcomes of that should be to rehumanize care, meaning that we are going to use AI automation to process administrative, low value technical tasks. And then we will free time to the HCP for the patient relationship development. We have also rising expectation. Mostly all of us, we want health and wellness. So not being sick, but having well-being as well. We want easy, fast, and equitable access to care at zero risks. What is the reality behind that? 26% of people renounced to care in France last year. We have increasing waiting time for specialists, and we have no equal access to care. It's very unfair whether you are living in a big city or you are living in a rural area. You don't have the same survival chance when facing an acute event. And health is high codes with health spendings growing faster than GDP, and that's an issue because we have to choose where to put money, especially when we know that structural costs are going up. How to keep the sustainability of our health system in that situation? Maintaining fundamentals principles, that is, equitable access to care. Here we can see that telemedicine and edge computing can solve that issue by being able to put AI-powered edge computing device in rural areas. You can bring the expertise of the best expert in medical desert. The accountability of the patient who owns his her health data with connected health is also one way to structure the market with the blockchain and to make the best out of this data to be more preventive, more proactive. And then we have financial solidarity, the efficiency of care system, and basically these are enterprise grade solutions such as enterprise resource planner, customer relationship management, performance dashboarding. And obviously, first we need to not doing harm to the patient, primum non nocere. So, how can we entrench the health ecosystem when facing this sustainability critical issue? First comment is that the reimbursement architecture so far is not in favor of innovation. We reimburse medical acts and procedures, but not the quality of it. So any startup claiming a piece of cake because it improves the quality of the medical procedures, that's not the right business model. You are simply taking money out of the pocket of the healthcare professional. We need to improve operational excellence with automatic smart workflows, fraud detection, and better real-time insights of current demand. We need also to change business model of the private sector, and drug discovery is a big issue because we really need to be smart in that field, and we need to take into account physiopathological patterns and not only dumb correlation made in a big data lake that correlates the age of the octopus with the number of tentacles of the captain. It's nonsense. So go back to the foundations. There are physiopathological patterns, and you need to build not correlations but causality. We also need to address public health policy goals compliance instead of just selling drug. It's going beyond your products, self-services. And we need to speed up clinical research kinetics while maintaining drug safety or rather risk profile. It's very challenging about the zero risk approach to the system. We also need to have a real-time capacity planning to provide guidance to re-architecture the healthcare system. With embedded digital transformation initiative, we should not be able to build a new hospital without taking into account this digital transformation. And we need also real-time dashboarding to help the offerings to meet the demands. Regarding the university med schools and councils, they need to embrace smartly new technologies for better healthcare. HCP must be trained, initial and continuous education, to use the new technologies. And they must be able to team up with these new technologies to deliver better health and better care. And this means to better understand their limits and how to use them at their utmost. Eventually, the healthcare providers need to leverage new technologies for better operational efficiency. We can think here about centralized, distributed, securely shared EMR, leverage automation of low administrative tasks, low value administrative tasks, and use ERP CRM-like systems to align offerings demand in near real times at any scale of the system, meaning at the hospital scale, local scale, regional scale, but also national scale. So, how do we start the digital transformation of healthcare system and healthcare ecosystem when investment capacity is so low and the whole system is craving for money? Let's assume you chose the blue pill and let's do a short travel in time 15 years from now in the near future. Just a glimpse ahead. Let me introduce you Paul, who is a big football fan and is doing sport, watching TV and eating ice cream on the couch. The Ouch watch detects arrhythmia and the FAMEDIAG unit sees increase in troponin. So what is FAMEDIAG? Remember, we are in a parallel world 15 years ahead from now. In that world, Theranos is still alive, and there are great success with the FAMEDIAG unit. It's a DNA chipset-enabled medical analysis device, and it makes up to 100 blood analyses with only one drop of blood. So the FAMEDIAG unit sees an increase in troponin. Another cool thing here is that troponin is a clear specific marker, biomarker of the heart attack with an excellent signal-noise ratio. You don't have a heart attack, troponin is very low. You have a heart attack, troponin is very high, basically. And it's very critical when you want to do AI diagnosis is that you need to select biomarkers. Remember the clinical presentation, so biomarkers which are specific with an excellent signal to noise ratio, because there's no algorithm that could separate weak signals from big noise. So it seems that Paul is doing a heart attack, a genuine one. So the outward says told you to run more, and meanwhile it calls 911. Behind the 911, there's a global supply chain management system that connects to Paul's EMR, check Paul's insurance plan, and check also traffic jam. Why? Because the global supply chain management system will send the mobile emergency care unit and route Pauls to closest appropriate care unit. The estimated time of arrival is 30 minutes, and the chosen procedures is ballooning plus tense. During transportation, diagnosis is confirmed by consultation, which is the bigger version of the family unit. First care is given, and the ultimate clinical assistant based on AI lists additional examinations for differentials. The global supply chain management system updates requests and book angioplasty room for immediate usage, cardio rehab bed for 10 days, and to be available in 48 hours, 2 days from now. Paul is transferred onto a robotic bed which is routed to the angioplasty room, and this is very important because currently a lot of patients are waiting for people that can push them from one room to another. So having a robotic bed is a very cool idea. The team is ready to process under the remote supervision of a senior radiologist using HoloLens V2 to supervise the procedure. 26 minutes later, procedures complete and Paul's routed to post-op monitoring. Heart attack plus 2 days. Let me introduce you to Paul's new best friend, the Ouch Bike, with gamification of cardio rehab programs. The clinical data of the heart attack of Paul has been updated and is feeding now the learning subset of the ultimate clinical assistant AI, which discards it because it's a very classical heart attack presentations with new information to learn at all. Obviously, it's discarded from the learning set of the UCAAI, but still kept into Paul's EMR. So what now? Paul has a new or the best friends, his personal diet rehab coach. It checks if Paul did not hide donuts in his drawer, but not only. It also provides insightful information, therapeutic education, remember, and daily drugs for observance because it's connected to the pharmacy ERP. 10 days have passed, Paul is sent back to home. Cardio rehab bed is put back into the availability pool, and billing is sent to Paul's insurance. Paul has his first remote medical consultation to check his cardiac recovery. His insurance health plan allows him not to be handled by the ultimate clinical assistant AI instance, but by a real dog, Lucky Paul. However, it's not a gold plan. This means the dog is from Vietnam and uses Skype translator to have a fluid conversation with Paul. Anyway, this dog is also assisted by the same UCAAI system, so it's pretty cool and pretty secure for Paul. His health insurance contacts Paul for a super deal, 30% off if he accepts to share his medical data plus personal health coaching. Well, Paul is hesitating a while enjoying a new ice cream. 2 years ago, he have accepted to have a GPS tracer in his car, and last accident, the car insurance company checked the data, and he was only half reimbursed because he was partially responsible of the car accident. Well, not a perfect word, but his insurance is still affordable with good package services, and he's still alive. This brief history of angioplasty was an illustration of an AI-powered patient circuit in a modernized healthcare provider system. From detection to follow-up, we were able to ensure that Poles would be still able to eat ice cream after that. So from detection to initial routing, stabilization, admission, therapeutics, and follow-up, we've seen that the global supply chain management system was able to route Pole into the systems, routing him to the appropriate um, capacities, and matching the demand with the resources, while the ultimate clinical assistant AI port was able to do the whole diagnosis to follow up of Paul's heart attack. The message here we want to convey is that this is not just a glimpse ahead. It could be right now from a technical perspective. We have all the levers to implement such solution. Like I said, brokers are the ability to invest cash in that digital transformation, the ability to structure the ecosystem and to find the right business model so we have a fair share value along the value chain, and also the resistance to change because it's very conservative ecosystem. But we have mostly all the technical components to be able to build such scenario in the very near future. At Microsoft, we are committed to make sure that Paul can still be able to eat ice cream in the near future. This is the reason why we developed all the technologies based on our free clouds, Office 365, Dynamics 365, and Azure, to be able to build all the technical components of this brief history of angioplasty scenario. Furthermore, Microsoft platform have the highest level of independent certifications, including the health industry. And for French data centers, they are certified HTS, the ability to host medical healthcare data in compliance with the French regulation. Takeaway: is it a revolution or an evolution? Remember the feudal logic, something in between. Narrow AI can only address simple closed questions. Melanoma, retinopathy, and general AI is still far from being a reality. However, it can do it very efficiently, but with clean data. Because its robustness is still questionable, noise, exotic clinical presentation could impair its ability to do the right thing. It has great potential to deliver medical services when there's none, with a better than average quality. And that's really in favor of equal access to healthcare. It has also great potential to assist HCP to deliver better care and to reduce the marginal cost of treatment through automation and friction reduction. There's a big challenge about training and change management to make the best of it. HCP should not be data scientists or developers, but they must know weaknesses and strengths of AI. There's also a big challenge about clean, qualified dataset to train AI in the healthcare industry. And it's no chance that it first started in areas where EMR were most developed, radiology and PACS. So, despite lots of initiatives, introduction of new product services on every innovation fair, business models and product service deals still need to be refined in terms of added medical value. So entrepreneurs have still broad space to innovate. Go for it. And what about doing it on Microsoft Clouds assisted by Microsoft Services Digital Architects? So we were talking about artificial intelligence and neural network. Here is a slide about the energy efficiency and versatility of deep neural networks. Here you have a multi-layer perception with 3 hidden layers, 10,000 neurons, more than 24 million synapses. And what's the goal of that ML perception? Basically, it's able to recognize figures from 0 to 9. Wonderful. Now, who's the opponent? Let me introduce you the fruit fly. 135,000 neurons, so about 13 times more, but not only to recognize figures from 0 to 9, as it exhibits many complex behaviors, hundreds of different behaviors indeed: feeding, grooming, flying, mating, learning, whatsoever. And so the true question here is about the thermodynamics of your natural neurons against ML perception. And the fruit fly, it's only a few watts in terms of power, while to feed these ML perceptions, I guess that it costs much more energy just to recognize figures from 0 to 9. Maybe you know this quote. It says, "Man is the lowest cost, 150-pound, nonlinear, all-purpose computer system which can be mass-produced by unskilled labor. And that's the reason why we sent men to the moon instead of sending computers, especially when you have a look to the computer on the right." And my prediction is far from being the same as Yuval Noah Harari. In 2030, man would still be the lowest cost, 180 pounds. Yes, there's a metabolic syndrome pandemia on Earth. Nonlinear, all-purpose computer system which can be mass-produced by unskilled labor and trained at a very low thermodynamic cost to learn medicine. Thank you very much for your attention.